Good afternoon, ladies and gentlemen. My name is Pablo. We are the team number 8, who is conformed by
Francisco,
Sebastián,
Patricio,
and Gerardo.
Our objective in this final challenge is to build a chain reaction system. This chain reaction system needs to include a spring, a circular motion, collision, and a projectile motion.
We are going to explain how we did our final physics project.
Okay, so first up, we're gonna start out with a spring that we built off of a metal string that we tied around a wooden stick. So our spring is gonna compress and hit this Valero that's gonna act in a circular motion and hit the little ball we have right here. The ball is gonna do a projectile motion from the table to the floor and hit these wooden sticks that are gonna hit the dominoes and in turn go all around and finish our chain reaction.
The construction of the prototype consisted of aligning both dominoes and wood blocks in order to create the classic domino chain reaction. In order to trigger this domino chain, whilst having a spring, collision, and projectile motions involved, we taped a Valero in a table, which would then have the spring provide the force necessary to rotate and hit a ball. This ball then would fall off the table, creating the projectile motion and triggering the final domino chain, powered by the wood blocks. We used tape to measure things such as the table's height, the spring's movement, and the radius of both the Valero and the domino circular motion. We also created our own spring with a drill and a single piece of straight metal string.
At the beginning of the chain reaction, we have a spring that will push the Valero and then hit the ball to make a collision between the Valero and the ball. We put the velocity of Valero in negative because moved in negative axis of x. With this equation, we find the initial velocity of the ball. We have a conservation of energy where the energy of springs acts first and then acts the energy of kinetic and rotational. The circular motion is composed by the tangential velocity, angular acceleration, and angular velocity. But this motion does not make the complete turn. In the projectile motion, we have the angle of the ball, which is 0, and that demonstrates the ball is not moving on y, only on x. To find the displacement of the ball, we used two equations. One for find the time, and after that, put it in the equation of displacement in x.
After building the chain reaction system, we can say that we have completed our objective. The system is constructed by a collision, a projectile motion, a circular motion, and the spring.
For this challenge, our possible sources of error include inexact measurings, be it from the weight and the mass of the objects that were involved in the chain reaction, to the length, maybe the height of the table, or the length of the string in which the Valero rotated around. Also, the air resistance that acted upon the ball when it was falling and acting in a parabolic motion, and also our calculations from the experiment, maybe the decimal places, etc.
In our video, we include a projectile motion, angular motion, a collision, and a use of a spring like Weiss and Fischli did in their video. However, we did not include chemical reactions, fluids, explosions, etc., but at least we made a similar procedure of the system like them.